Deep within the heart of mountains, massive machines slice through rock, clashing technology against nature. And through these clashes, the wonders of the modern world are born. Tunnels spanning thousands of meters connect the two sides of the mountains. In China, these engineering marvels are becoming a common sight. But how is China building these miles-long tunnels so fast? Let's find out.
The beginnings. The first question that may pop into your mind is, why does China build a tunnel in the first place? Surely building a road is much easier and less expensive than digging through an entire mountain made of hard rock. Well, to China, it is always about the long game. They don't just see the immediate gain, but also the long-term benefit. You see, normal roads have to wind around a mountain, snaking up with every twist and turn. Compared to that, a tunnel cuts straight through, turning the journey that would have taken hours by road into a matter of minutes. And this comes in clutch in the long term. This faster transit time translates to economic growth as people and goods can reach their destination faster. In just a few years, the millions China spent on building that tunnel will be recouped and keep giving back more in the form of job creation, talent distribution, and trade. But that isn't the only reason why China is building tunnels left and right. Turns out these things are actually saving lives. Landslides are an ever-present threat to highways and roads built to cross mountains. One moment it is all calm, and the next a hail of rocks comes crashing down, destroying anything it encounters. And then there are those dangerous turns that hundreds of cars fall victim to every year. Tunnels don't pose these issues. They are a controlled route where most dangers are removed. And even if the worst comes to happen, there are safety protocols and evacuation systems in place to prevent harm. When you take all that into account, it becomes clear why China, a country that is making a huge effort towards making its economic centers more connected, is building so many tunnels. Now that we know the why, let's move on to the how. Creating a tunnel that cuts right through a mountain is certainly no easy task. It's a complex process that begins months, even years before even a single rock is moved on the site. The very first thing that happens after China has decided to build a new tunnel and all the paperwork is done is land selection. After all, engineers cannot just randomly pick a spot and start digging. There are a lot of factors that go into this process. Engineers pore over geological maps. Several different routes are selected, and among them, only a few make the cut. Boreholes are dug throughout the area where the tunnel is going to be to conduct tests. Additionally, cutting-edge ground-penetrating radars are deployed to map out the underground region and see if any significant faults exist. What they are looking for in these tests is whether the proposed routes have the right rock density and are stable enough to sustain the drilling process. They also look out for water aquifers or underground caves that may crisscross through the path, as they can add another layer of complexity for the project in the future. Experts go through this arduous process over and over again until they find the right land. And then the planning begins. This step involves figuring out the route in detail, determining what type of tunneling method is ideal for the project, and determining the dimensions of the tunnel. An entrance and an exit point for the tunnel are selected and all the arrangements are made. Contracts get assigned, equipment is acquired, and materials are sourced. This process alone can take months, but that doesn't mean things are at a standstill. Experts continue conducting tests to determine the feasibility of the project. At the same time, factories around China start manufacturing prefabricated components. China is a pioneer of prefabrication, and its tunnels are one of the mega project types that get the most advantage out of it. The tunnel liners, support walls, ventilation ducts, all of these things are prefabricated to save time and effort once the project actually begins. Compared to other countries, China prefabricates more materials for its tunnels, and by doing so, it is able to build faster and more efficiently. Once all that is done, it's time to dig the tunnel. Now there are several different ways China digs its tunnels. The most popular of them all is using TBMs.
TBMs. TBM stands for Tunnel Boring Machine. And what exactly are those? Well, think of these like giant drills that are as large as the tunnel they are digging. These giants are designed to be a complete powerhouse that can cut through nearly any naturally forming rock effortlessly. So, slicing through a mountain is no big deal when you have one of these, and China makes great use of these marvels of technology. But the question is, how to acquire one of these? The answer, at least for China, is incredibly simple. Just build one of them. You see, China is currently the top manufacturer of TBMs in the world. They are at the forefront of this technological innovation that is changing landscapes around the world. China is so good at building these that other countries come and buy their TBMs from China. So when China needs to build a tunnel, they simply have one of their state-owned companies make one. And that is no simple process. Building one of these TBMs requires months, even years of work. That's because each one is customized to the kind of project it is going to be used in. The type of land, depth, and rock types the TBM will work through all play a factor in component selection. First, experts create a 3D virtual model of the machine and run tests on it. And when everything has been refined down to perfection, the real work begins. Over the coming months, the components are sourced and the TBM is put together. Every component used is built domestically, no outsourcing. And once the TBM has been custom designed for the workload it is going to face, it is taken to the excavation site, where the tunnel is going to start being dug. This is usually done by disassembling the TBM into sections, transporting them separately, and then reassembling them at the site. And there is a good reason why that is necessary. TBMs usually weigh hundreds, even thousands of tons. And for a large tunnel, you are reaching the absolute limits of TBM size, reaching over 5,000 tons. Once the TBM is on site, the digging process actually doesn't start as you may be thinking. They don't set it on the ground and let it run into the mountain. Doing something like that would cause a landslide quite easily, bringing heavy rocks down on the expensive equipment and workers. Instead, the experts dig what is known as a launch shaft. What is that? It is a vertical shaft that is dug during the preparation for the tunnel's construction. It is large enough to accommodate the TBM and has been checked thoroughly for structural integrity. Think of it as the starting point for the tunnel. This point has been selected after careful testing to be the best place to start drilling, and it places the machine at the perfect height needed for the tunnel.
The sections of the TBM are lowered into this shaft using powerful cranes. The cutter head is the toughest part to get down there since it is the heaviest and largest. But once everything is safely down there and the engineers have assembled the TBM, work can at last begin. And how these TBMs work is quite fascinating. The main component being used is the main cutter head. This gigantic disc is made of a hard metal with blades attached to it, and the entire thing is rotated using a powerful motor. With each spin, it cuts into the earth, breaking apart rocks and slicing out the dirt. Think of it like a drill head. But just like a drill head, this cutter head is also only a part of the equation. There needs to be force pushing it into the rocks to make it function, and that force comes from hydraulics. The TBM has an extensive system of hydraulic mechanisms that often extends tens of feet behind the cutter head. The TBM anchors onto stable points and pushes itself forward with so much force that the earth itself gives way. And while all that is happening, another thing is happening at the back. There are mechanical arms usually installed on TBMs in the factory that serve a very specific function. These arms are designed to install prefabricated tunnel line slabs in the back. These concrete segments have been prefabricated in a factory as well, and they are installed simultaneously as the TBM progresses with the digging. And these segments actually serve a dual function. The primary function is, of course, to line the tunnel to provide support, helping prevent cave-ins while also functioning as the very base for future addition of tunnel lining. The other major function of these segments is to act as braces. Remember I mentioned how TBMs use hydraulics to push themselves forward? Well, in most modern models, the TBM is actually bracing itself on these concrete segments to push forward, as they serve as a consistent surface to attach to. This way, the operators don't have to constantly find or create a bracing point for the machine. The process is automated. Now, as the TBM is pushing forward, another thing is happening. A slurry, kind of like muddy water but thicker, is being pushed out of the machine. This water is actually the crushed rock and mud that are being excavated by the cutter head. You see, to aid the cutting process, the TBM is usually pushing water into the area being cut. This water helps reduce heat, makes clearing away the debris easier, and also reduces wear. TBMs have special channels built in that allow them to push out this slurry, but it's not like it's going to waste. For most tunnel excavation sites, they don't have an unlimited amount of water, so they have to get creative. A recycling plant is installed on the surface, which is connected with the TBM. The slurry is carried to the plant via pumps. All the mud and rock are extracted, and the now clean water is pushed back into the TBM for another cycle. This way, the engineers are able to minimize the impact on the environment while also maintaining an uninterrupted workflow. And that's how a TBM progresses through the tunnel, clearing a few feet every hour. A slow and steady progress powered by powerful motors, hydraulics, and exceptional engineering. But it is important to understand that these TBMs are extremely sophisticated devices. They are lined with sensors that are constantly monitoring not only the machine, but also the surroundings. A modern TBM has detection systems for dangerous gases like methane and hydrogen sulfide, while also monitoring the oxygen levels. TBMs also have seismic prediction tools and ground-penetrating radars constantly monitoring the surroundings to identify any possible instability that could result in a cave-in. If anything seems to be going wrong, alarms blaze and the workers evacuate. And as a final benefit, these machines also have a shielded area that helps protect workers.
The only problem is that as these giants move forward, digging through the ground, they kick up quite a lot of dust. This is why a very sophisticated ventilation system is installed and extended alongside the tunnel. This system evacuates all the dust from the tunnel to make it safer to work in. Additionally, there are navigation systems built into the TBM to guide it along the planned route. The work is precise to the extreme. These machines don't stray more than a few inches from the assigned route, even after digging for miles. Slowly but surely, the massive machine digs out the extensive tunnel, slicing through the mountain's roots in the process. And eventually, after months of work, it reaches the last stretch. The end comes near, and awaiting at the finish line is a reception shaft. This is much like the deployment shaft, but it serves the opposite function. The TBM breaks through into this hollowed-out vertical cavity in the earth where its journey ends. The story doesn't end there, though. The workers cannot just leave the TBM lying here blocking the exit of the tunnel. The TBM needs to be removed. There are two ways that is done. The TBM can either be disassembled, removed from the reception shaft in pieces using a crane, and then loaded back up onto trucks to be taken to its next project, or it is laid to rest. You see, most TBMs are just built to fulfill their targeted project, and then they don't have any use left. They are custom built with the requirements of the project in mind, meaning they are not suitable for another tunnel that will have different conditions and specifications. And if a TBM cannot be reused, it is disposed of in a very interesting case. Workers dig out a giant hole in the ground. The TBM is then lowered into the hole, and it is filled back up with dirt. More often than not, this burial is done right around the exit of the tunnel with the road built above it. Once that is done, it is time to decommission the shafts. Both the launch shaft and the reception shaft are filled back up with dirt as well. Just like that, the tunnel is finished, an arduous journey completed after months of effort. But it's not like digging with a TBM is without its own risks. If the ground conditions aren't right, the entire thing can sink or get buried in a cave-in. Not only that, since hydraulics are involved in the process, there can be deadly hydraulic leaks and even blowouts from the slurry. Workers operating these things and working around them risk their lives and limbs every day. Still, TBMs are considered the safest tunnel excavation method in the world. But that doesn't mean they're the only way China has of building tunnels. That's because in some cases, a TBM may not be the best choice for the job. If the ground is too hard, has varying density, or the route is simply too curvy, a TBM won't be able to handle it. In those cases, China opts for a different tunnel excavation method, one that is a bit more explosive.
Bomb blasting. China doesn't just know how to dig tunnels using TBMs, they have a long history of excavating using explosives, and they have it perfected down to an art. The first step is, of course, surveying. The process is a lot more rigorous here compared to TBM excavation, and that's because explosives create a lot more seismic disturbance, so the route of the tunnel and the ground being dug through have to be studied extensively to ensure they are stable enough to handle the vibrations. Tunnels dug this way also have a starting vertical shaft dug to start off the digging process. What comes next is a repeating cycle. Blast after blast will help progress the tunnel until it reaches the end point. Here is how it works. The first step is drilling. Experts create holes throughout the surface that they need to blast through to clear the next section of the tunnel. These holes serve two functions. First, they hold the explosives in place, and secondly, they allow the charge to be placed very deep into the rock that needs to be blasted open. This way, the force is directed where it should be, instead of back into the tunnel that has already been dug. Once the holes are finished, explosives are stuffed into them to the very end. Attached to these explosives are fuses. These fuses take a long time to burn through, and there's a good reason why. Once the main fuse has been lit, the workers have to get as far away as possible from the area. The longer fuse time allows them to get far enough away. Slowly, the spark progresses as the workers run for cover, and once this spark reaches the explosives, it's a huge boom. The placement of the explosives has been carefully measured. They are placed perfectly to target the weak point of the gigantic rock blocking the tunnel's progress. Each explosion across these holes is like a giant hammer pulverizing the surroundings. The order of the explosions, their intensity, and their timing have all been pre-calculated for optimal results. And these results aren't immediately visible. That's because the explosion kicks off a cloud of dust that would take hours to settle. But the workers don't have that kind of time. They have already installed a ventilation system system that kicks into action as soon as the bombs go off. It sucks up the dust in a matter of minutes, revealing the expected. Where there was a giant boulder are now these smaller rocks, and to clear the path forward, they have to be removed. But approaching those now wouldn't be a good idea. When such an explosion occurs within the bowels of a mountain, it often weakens the surrounding. Before the workers can go anywhere near the excavated area, they need to check the structural integrity. Experts do so using advanced tech like ground-penetrating radar and even robots. In some cases, if the area is deemed safe enough, the workers approach. But before they can touch any of the debris, they first need to add supporting structures to maximize their own safety. These prefabricated supports help hold everything up to further reduce the possibility of a cave-in. With all that done, the workers at last begin removing the debris, clearing the way until all the smaller stones are cleared away. And then the cycle gets repeated when a big boulder is encountered again. Explosion by explosion, the tunnel keeps on extending until eventually it reaches the end. This method of tunnel construction is quite fast, but at the same time quite risky. Even a small mistake can be deadly, which is why China is slowly phasing out this tunneling method entirely. It is not as common anymore as it used to be, especially since China is now moving towards another tunneling method called sequential excavation.